So we did do that. We did do this example last time, but I really just want to go through it because, again, I just feel better doing that. But this is actually illustrating how exponential functions can appear in the sciences like chemistry. You know, there are elements that can radioactively decay. You know, they radioactively break down. There is something called half-life. The book does not cover half-life, but it is something that comes up, though, in the sciences. And it is based on exponential functions. Okay. But so this is an example I just made up. So some new substance has been discovered, right? I'm calling it element X, okay? I'm calling it element X. And it turns out, somehow we found out, I don't know how they determined this, but it radioactively decays by about 21% each day. So in other words, 21% of the remaining element breaks down every day. So if you start out with some of the element, after a day, 21% of it is gone. Another day passes, another 21% is gone, and then so on and so forth. So every day you're losing 21% of what you have. So it's decreasing, the amount is decreasing by a constant percent. Well, that tells you it's going to be exponential. So let's suppose we have 200 milligrams of this substance. We want to know how much is going to be left after 1 week. Well, again, it's decreasing at a constant percent rate. So our R is 0.21. And since it's decreasing, okay, since it's decreasing, we have 1 minus 0.21. 200, again, is the initial amount, but it's 1 minus 0.21. If somehow it was growing instead of shrinking, if somehow it was growing instead of breaking down, then we would have addition, but we just have subtraction. Okay. Remember, the R has to be a decimal, not a percent. So this is a function that gives us how much is left X days later. All right. Okay. So again, I'm pretty sure this is on the notes I sent. I will post a full set of notes, you know, today or tomorrow. I really want to post them as soon as possible. All right. But basically, f of 7 then, which is how much is left 7 days later, that's what this is. And I did check this calculation. This is actually correct. I think, let me just. Okay. All right. What about it? Okay, so now number 2 is basically asking you how much is going to be left after 14 days. So again, we have 200 milligrams we're starting with. What about 14 days later? Well, in that case, we're not going to replace X by 7. We're going to replace X by 14, and we get this. So we get this. Okay. And now what's interesting is, yes, it's getting smaller how much is left, but you're never going to have 0. In other words, exponential functions will never give you an output of 0. They get very close to 0, but you can never get 0. I don't know if this really illustrates it, but how much is going to be left after 30 days? Well, in that case, your X is 30 and you get 0.17. What might happen is if you keep on replacing X by bigger and bigger numbers, this number, the output, might get so small that the calculator will just give you 0. But in reality, it's not. It's a very small positive number. So it's just something I wanted to point out. I thought it was cool. Okay. All right. Okay, so here's another example. This is actually more like half-life because now this is a new substance and it's decaying by 50%. It's decaying by 50%. So in this case, after each day, 50% is of the substance is gone. 50% of it is gone. But again, let's say we have 1,000 milligrams. How much is going to be left after X days? Well, it's kind of like what before, right? In this case, our R is 0.5. It's breaking down and by a constant percentage rate of 50%. So our R is 0.5, and we have this. So this is what we end up with. Okay? Okay, that's good. This is what we end up with. Then, okay, then what we have to do is, then what we have to do is this. We're going to determine how much is left after a week. Well, a week again is 7 days, right? So we'll have that amount. Okay. All right. Now, okay, let me just stop the recording and restart it. Because again, you know, the recordings, actually, no, I can keep going. Let me, all right. So the next one's going to be kind of interesting. How much is left after 9 hours? Okay? 9 hours. Let me just give you guys 5 minutes to try this out. Okay. You know, try it out for like about 5 minutes. Give it a shot. Okay. And here's a hint. You know, there's 24 hours in a day. About 5 minutes to try it out. Okay. We want to know how much is left 9 hours later. Right? But again, this is a little bit tricky, right? Because if you go back, our function, the input x, is not in hours, it's in days, right? So what do? Well, we know there are 24 hours in a day, right? So what we can do is we can do a conversion. I mean, you could use the factor label method, you can use proportions, either one. I used proportions, right? There are 24 hours in a day. So we want to know how many days 9 hours is, right? So we have this proportion and we want to figure out what x is. Well, how do you do that? Well, from here, I took the units away. And what do we do? Remember what you do next? You cross multiply, right? So we have 24 times x equals 1 times 9. And so, of course, we have 24x equals 9, and then we divide. So we get 0.3750 days. That's what we get here. So again, what did I do? I converted from hours into days. So I converted 9 hours into how many days? Okay. And that's what I'm doing here. We form the proportion, we cross multiply, okay? And then we get this. So using our function, we replace x with this number. I converted it to a decimal only because if I put the fraction up here on the slide, it may not come out right. So I converted it to a decimal. You can plug in a function, you can plug in a fraction directly, but this is what I get. Yeah?
So when I divided like 9 by 24, I got like, I think my calculator rounded up to 0.4.
Oh,
And
you
then like when
rounded
I
it?
did it, yeah, my
You
calculator
don't,
automatically rounded.
oh, because you want to make sure you only round at the end. Yeah, so
Okay.
your, does your computer, if your computer has a calculator, use that. Or you can use Desmos. Desmos has a free calculator.
Okay.
Okay, wait, does that, okay, hold on. Does that answer your question?